All right, let's get right into it. We're going to unpack the science behind our rising seas. But here's the thing. This isn't just a story about inches and millimeters. Nope. It's a story about speed, about a fundamental change in the rhythm of our planet's oceans. And that whole story kind of starts with this one, pretty startling number from NASA. Just in 2024, the global sea level jumped by 0.23 inches. Now, I know what you're thinking. That doesn't sound like a lot, right? But here's the kicker. It was way more than scientists were expecting. And you don't have to take my word for it. Listen to NASA's Josh Willis. He said the rate itself is getting faster and faster. And that acceleration, that's the real story here. It's a huge signal that the engine of our climate system is shifting gears right under our feet. To really get why this is such a big deal, we've got to look back at the data. I mean, we need some context. Because this recent speed up isn't just a blip on the radar. It's a dramatic break from a very, very long time of things being pretty stable.
Okay, just look at this timeline. For almost 2,000 years, a flat line, sea levels were remarkably stable. Then, right around the 1850s, that changes. In the 20th century, we saw a rise of about 1.5 millimeters a year. But then, starting in 1993, boom, it more than doubled. And today, the rate we're at now is triple the 20th century average. That curve is just getting steeper and steeper.
So we know it's speeding up, but why? What's actually pushing the accelerator on this thing? Well, it really boils down to two main, pretty simple physical drivers.
First up, thermal expansion. It's simple, really. As the ocean absorbs more heat, the water itself actually expands. It just takes up more space. And second, this is the one we all see in the photos. We're adding brand new water to the ocean from melting glaciers and, those enormous ice sheets in places like Greenland and Antarctica.
And get this, in 2024, that year with a surprisingly high jump, the main culprit was thermal expansion. You see, 2024 was the warmest year on record, so the oceans literally swelled up, accounting for 2/3 of the rise all by itself. It's basically high school physics, just playing out on a massive planetary scale. And this diagram really shows you how it's all one big connected system. It's not just some ice melting over there and water rising over here. It's about heat moving through the atmosphere and the ocean. It's about currents carrying that heat all over the globe. Every single part of the system affects that final number we see at the coastline.
Okay, so that's the story of the past and the present. But the really urgent question on everyone's mind is, where are we headed? So let's shift gears and look at the projections to see what the science is telling us about what's coming next.
So what does the future hold? Well, here's the interesting part. Science doesn't give us a single, sealed fate. It's not like that. It gives us a menu of possible futures.
And that's exactly what this chart from the IPCC shows. See all those colored lines? Each one is a different path, a different scenario, based entirely on the greenhouse gas emissions we as a civilization produce. The red lines up top, that's a high emissions future. The blue lines at the bottom show a world where we make some serious cuts. The biggest takeaway here, the future isn't set in stone. It's directly tied to the choices we're making right now.
Now, you might be wondering how scientists can even predict this stuff. Well, they think in probabilities, and this is a really key concept to get. On one side, you've got the likely range. This is based on processes they understand really well, like thermal expansion. But on the other side, they have to account for these low-likelihood, high-impact events. Think of these as the wild cards, like the sudden rapid collapse of an entire ice sheet.
And it's not just global. Agencies like NOAA take all this worldwide data and bring it right down to a regional level. As you can see here, their scenarios for the U.S. show this whole spectrum of possibilities, from low to high. This gives coastal communities a clear look at the full range of risks they need to start planning for.
And to make this super real, let's just zoom in on California. In what they call an intermediate scenario, the state could see about 3 feet of sea level rise by 2100. But under the high scenario, that less likely but still possible wildcard, that number jumps to over 6.5 feet. And look out to 2130, the difference is between 5 feet and a truly staggering 10 feet. The gap between these futures is absolutely immense.
So let's talk a little more about those wildcards, because a growing number of scientists are getting really concerned that something that was once considered a long shot might actually be more probable than we thought.
I mean, just look at this headline. This captures that growing concern perfectly. New research is suggesting that a major tipping point, one involving a massive current system in the Atlantic, could be way closer than we understood.
What they're talking about is the Atlantic Meridional Overturning Circulation, or AMOC for short. The easiest way to think about it is like a giant conveyor belt in the ocean. It moves warm water north and cold water south. It's basically a critical engine for our entire global climate. And if this conveyor belt shuts down, well, the potential impacts are frankly terrifying. It could shift rainfall patterns that millions of people depend on for food. It could plunge Europe into extreme weather. Oh, and it would add another 1.5 feet of sea level rise on top of everything else we've talked about. The scariest part? Some models suggest we could cross that irreversible tipping point in just the next decade or two.
Okay, so whether it's a slow, steady rise or it's spurred on by one of these wildcard events, let's bring this all back from abstract numbers to what it actually looks and feels like for people living on our coasts.
And this picture? This really says it all, doesn't it? This isn't some abstract computer model for the distant future. In places like Pacifica, California, homes and roads are already threatened by a coastline that's crumbling away, and that process is sped up by every single fraction of an inch the sea rises. The physical effects are just all over the map. We're talking more frequent sunny day flooding, sure, but also the permanent loss of low-lying areas. The groundwater actually rises up from below, threatening things like pipes and cables buried underground. Saltwater creeps into our fresh drinking water. Cliffs and beaches just wash away faster. In fact, get this, Southern California could lose up to 2/3 of its iconic beaches by 2100 if we don't do something major.
And all of that brings us to the final, and honestly, the most important impact. Because at the end of the day, this isn't about geology and infrastructure. It's about us. It's about people.
You see, as coastlines are reshaped and become literally uninhabitable, rising seas become a powerful engine of human migration and displacement. It's a quiet crisis that's already starting to unfold in vulnerable communities all over the world.
And the potential scale of this is just staggering. 1.2 billion people. Just let that number sink in. That's a prediction from the Institute for Economics and Peace for how many people could be displaced by 2050 from all kinds of ecological threats, with sea level rise being a massive one. Which brings us right back to where we started. The science isn't showing us one single locked-in future. It's showing us a range of possibilities, from the difficult but manageable to the absolutely catastrophic. The data makes it crystal clear that the path we end up on is being decided right now. So the final question isn't just what does the science say, it's which of these futures are we going to choose to create?